So in analog electronics, we have discussed the concept of inverting amplifier, non-inverting amplifier, and application of operational amplifier. This particular topic that can be discussed in this particular class related to analog electronics. So first of all, we have start with new topic which is known as inverting amplifier, which is known as inverting amplifier. So what is the meaning of inverting amplifier? What is the meaning of inverting amplifier? See, this is the symbol of operational amplifier. This is known as negative terminal. This is known as positive terminal. If positive terminal, that I have connect with ground, and here if we can give the supply voltage, here we can say plus VCC, here we can say minus VEE. So if you can give the supply voltage, here if you can give the supply voltage at inverting terminal, so it can be considered as a inverting amplifier. So it can be considered as a inverting amplifier. Now this is considered as a open loop. This is considered as a open loop configuration. This is considered as a open loop configuration, and this is known as inverting amplifier. This is known as inverting amplifier, open loop configuration. Now, what is the output voltage? What is the output voltage? So, non-inverting terminal connected with ground, that's why it is known as non-inverting amplifier. Now, say this is inverting amplifier with open loop configuration. Means what? Here we can say negative terminal. Here we can say positive terminal plus VCC minus VEE. Non-inverting terminal connected with ground. See this. And here we can say output voltage. Now, if you can apply, See, see this type of input that can be applied, it is known as V in. Here it is known as V out. So what is the maximum value of output voltage? First of all, write down here main point of this theory. Non-inverting terminal non-inverting terminal terminal connected with ground. So it is inverting amplifier. It is inverting amplifier. So here we can say, and this is the symbol of operational amplifier. This is the symbol of operational amplifier. Operational amplifier consists of 25 to 26 transistors. Often consists of more than 26 transistors. Op-amp consists of more than 26 transistors. So, if you can connect more than 26 transistors in the circuit, at that time, what is the output voltage? Remember that point. I have right here. For any transistor, for any type of transistor, I have right here. Please carefully see this. For any type of transistor, output voltage is not higher than plus VCC. Please carefully read this statement. Whatever I have highlighted here, see this. Whatever I have highlighted here, please read this very carefully. Out for any type of transistor, output voltage is not higher than VCC. Means what? Maximum output is plus VCC. So, if any signal that can be passed through 26 transistor, any signal, suppose V in equal to, we can say, assume that 10 microvolt. So if 10 microvolt that can be applied across op-amp, then this signal can be passed into the 26 transistor. So what is the output voltage per transistor? We can get maximum output VCC if we have assumed that. Then what is the maximum output which is known as either minus VEE or plus VCC. Either minus VEE or plus VCC. So here we can get minus VEE and here we can get plus VCC. Here we can get plus VCC. So it is the minus saturation level, it is the plus saturation level. So it is the waveform related to open loop configuration. Waveform related to open loop configuration of inverting amplifier. Please highlight my word, or I have write here separately. It is considered as a open loop configuration. It is considered as a open loop configuration. Now, what is the limitation of open loop configuration? I have speak verbally, and in my next canvas, I have write individual point. See this input and output waveform. This is input waveform. This is output waveform. If you can see this minor, if you can see this very in depth manner, then you have visualized that in positive cycle, if voltage is changed, see this, here 0 volt, here 1 volt, here 2 volt, here 3 volt, here 2 volt, here 1 volt, here 0 volt. If voltage is changed in positive cycle, but output voltage is constant, which is known as minus VEE. Similar type of application, here voltage is decreasing, then voltage increasing, but still output voltage is constant here. Means what? If voltage is increasing any such a way that in terms of microvolt, then output is fixed, either minus VEE for positive cycle or plus VCC for negative cycle. So what I am trying to say that, see, this is the region at which we can get output voltage in maximum value only. So we can say that one type of non-linear application that can be designed using this particular open loop configuration. So what is the disadvantage? What is the disadvantage? Non-linear type of application, non-linear type application using op-amp, using op-amp can be designed in open loop, and we cannot able we cannot able to design linear application using open loop, using open loop. So so here I write, here I have mentioned that limitation of open loop configuration. Limitation of open loop configuration. Non-linear type of application using open can be designed in open loop, but and we cannot able to design linear application using open loop of open. So for converting from non-linear application, non-linear application of op-amp into linear application, so we can introduce the negative feedback, we can introduce the negative feedback to input. We can introduce the negative feedback to the input. So how introduce negative feedback? See this diagram very carefully. See this is plus VCC, this is minus VEE. This can be connected with ground. This is known as VE. This is known as RS. This is known as RF, feedback register. Due to feedback register, gain of operational amplifier that can be contained, gain of the operational amplifier compared to open loop is reduced. In open loop, gain of the operational amplifier is infinite. Why infinite? Because if input is applied very low value, then output is high. Or we can say plus VCC or minus VEE. That's why V out divided by V in. That's why for open loop, for open loop, voltage gain equal to V out divided by V in. So AB equal to, what is the V out? 15 volt divided by 20 microvolt. Assume that this is 20 microvolt. So 50 divided by 20, 15 divided by 2, so 75 multiply by 10 raised to 5. See this. 10 raised to 5 means ideally infinite. 10 raised to 5 means one type of lakh, 1 lakh, 2 lakh. This type of gain can be practically not possible. So ideally infinite gain we can get from the open loop configuration. This is the limitation. This is the limitation. Output voltage must be remained to control. That's why one feedback register, that's why one feedback register is introduced here. This feedback register is introduced here. What is the function of this feedback register? What is the function of this feedback register? This feedback register introduce the negative feedback. See this my different color pen dot color marking. This introduce the negative feedback. This introduce the negative feedback. So gain is reduced. So gain is reduced from 10 raised to 5 to 1, 2, 3, 4 like that constant figure. So it is the advantage of inverting amplifier with closed loop. Inverting amplifier operated in which mode? Closed loop. So here it is mentioned for open loop, already discussed in the previous case. Now I would like to erase this portion. Now for closed loop, Now for closed loop at non-inverting point, if here 0 volt, then here also 0 volt. Why? Because infinite resistance that can be created at the inverting and non-inverting terminal. So for closed loop, non-inverting terminal, non-inverting terminal connect with ground. So infinite resistance, infinite resistance that can be developed, infinite resistance that can be developed between op-amp terminal, infinite resistance that can be created between op-amp terminal. Which terminal that I have mentioned here? See this infinite resistance that can be created between inverting and non-inverting terminal of an op-amp. Infinite resistance that can be created between non-inverting and inverting terminal of op-amp. Why? Because inside op-amp, one stage is present, dual input, balance output, differential amplifier. And differential amplifier always contain high value resistance. So infinite resistance can be created between inverting and non-inverting terminal of op-amp. So, so there is no voltage drop. There is voltage drop. There is no voltage drop present at this terminal. So at non-inverting terminal, if 0 volt, non-inverting terminal contains 0 volt, then then at inverting terminal voltage is also 0 volt. This is the concept which is known as virtual ground. This is the concept which is known as virtual ground. This concept is known as virtual ground. This concept is known as virtual ground. Please see this very carefully. Why virtual ground? That I have explained with figure. See this figure very carefully. See this figure very carefully. Whatever I have shared here. See this. If here 0 volt, then due to infinite resistance present between inverting and non-inverting terminal, here it is inverting, here non-inverting. So here also 0 volt. So it is the concept which leads towards the concept of virtual ground. This can be leads towards the concept of virtual ground. Do you know inverting amplifier closed loop? That's why I have erased this figure, and I can say this is the concept of virtual ground. Please try to see this. Please try to see this dotted path. And I have clearly mentioned that which is known as virtual ground concept. This is known as virtual ground concept. Now, apply the KVL in the entire loop. So here, due to presence of 0 volt, this can be considered as an input loop. Please try to see this. This can be considered as an input loop, and this can be considered as an output loop. See this black indicator. It can be considered as an output loop, and it can be considered as an input loop. Here, it can be considered as an input-output loop. Now apply the KVL. Apply the concept of Kirchhoff voltage law to the input loop. First step here, apply KVL to input loop. This can be considered as an input loop. See this. So here V in equal to I into Rs or I into R1, simply we can say. And second step, apply KVL to output loop. So V out equal to minus I into Rf. Why minus sign? See this. This is the most important terminology. Why minus sign? That I have explained in the next point was mathematically. See this. Here 0 volt. Here voltage is V0. So 0 minus V0 divided by Rf. 0 minus V0 divided by Rf equal to I. Now if you can simplify, so 0 V0 equal to minus I into Rf. Consider this is the first equation and consider this is the second equation. Consider this is the second equation. Consider this is the first equation. Consider this is the second equation. So now if you can erase this portion, now if you can erase this portion, and if you can take the ratio of equation 1 and 2, with respect to 2, take the ratio of 1. So V out divided by V in, V out divided by V in equal to minus I into Rf divided by I into R1. I cancel. So here we can say V out divided by V in V out divided by V in equal to, we can say, minus Rf by R1, which is known as gain of non-inverting inverting amplifier. Minus sign indicate input and output signal is 180-degree phase shift with respect to each other. Input and output signal is 180-degree phase shift with respect to each other. Negative sign indicates this value. Input signal and output signal are 180-degree phase shift with respect to each other. Take the ratio of equation 2 and 1. Equation 2 divided by equation 1. So we can get this expression. This is the equation of voltage gain due to inverting amplifier. And if you can visualize this equation, then you have found that this equation only depends on Rf and R1. It does not depend on internal parameter of op-amp. It does not depend on internal parameter of op-amp. This is the advantage. Now, I have shared the new whiteboard with you. See this, I have erased the entire portion, clear all, and I would like to sketch the waveform. I would like to sketch the waveform. Diagram already mentioned in the figure, inverting amplifier. See this inverting amplifier, due to presence of this equation, V out divided by V in, which is equal to minus Rf divided by R1, means what? Output signal is 180-degree phase shift with respect to input signal. Output signal is 180-degree phase shift with respect to input signal. Means what? Here T, here V in, here V out. V out means what? Output signal is amplified, but 180-degree phase shift with respect to input. So we can get this type of graph. Here negative voltage, here positive voltage. So it is the diagram of which amplifier? Inverting amplifier. Inverting amplifier waveform. And now see this, if Rf equal to R1, then AV equal to minus 1. AV equal to minus 1. See this, AV equal to minus 1. So this is feedback resistor. It reduces the gain. What is the function of RF? Already explained. It is reduce the voltage gain. It is reduce the voltage gain. See this, in open loop gain is infinite, but here it can be reduced by minus Rf by R1. See this equation very carefully. So it is considered as the inverting amplifier voltage gain. Diagram already mentioned in the whiteboard. See, this is the diagram. RF means feedback resistor, supply voltage given to the inverting terminal. So it is the entire explanation related to inverting amplifier. In next lecture, we have discussed the non-inverting amplifier. Thank you very much.